Welcome back. Let's talk about the next period in the Paleozoic era. Let's talk about the Ordovician period. Shall we? I don't know what always does that. Anywho, so kind of by the middle of the Ordovician, this is kind of what Earth is looking like. Here's North America. You can see it has kind of shifted, rotated a little bit. It's still kind of separated from what we've seen. Again, North America, here's the equator. So not only are we shifting, we're moving a little closer to the equator. Here's what is modern day Arizona, just to give you a little bit of a reference. In the Ordovician, we start to get a decrease in atmospheric oxygen, a decrease in a rapid decrease in atmospheric carbon dioxide. And then towards the end of the Ordovician, we see this blue line, which indicates some glaciation near the poles that will be occurring. That becomes very, very important. So we're talking about 485.4 to 443.8 million years ago. A little chunk of time, but worth its while. Again, we got a sudden abundance of trace fossils. Remember back, trace fossils aren't the organisms themselves, but things that are left behind by the organisms. Tracks, poop, or other types of information. So anyway, we get a lot of that indicating, okay, we're seeing, again, some more different animal types. There was a massive extinction that occurred at the end of the Ordovician that we'll talk about, and that's hypothesized mostly due to the idea that massive glaciers formed around the South Pole. We saw that just in that previous slide with the little lines in the charts, that blue, indicating some glaciation. So when you get more ice on land, that water's got to come from somewhere. So if you're building up ice on land, then you're draining the ocean. So sea levels were dropping, so that caused loss of habitat in the shallows of the ocean and other atmospheric things. In regards to life, we do start to get some very primitive plants called lycophytes beginning to move onto land, which again, land was barren. There's nothing there until kind of the Ordovician. So we start to get these little tiny plants. More on that in a little bit. Later, other types of plants colonized terrestrial habitats. The ocean became filled with kind of invertebrates, things without backbones of many different types. And you also get with such things like bivalves. Bivalves, bi means two, valves means kind of side. So like things like, if you seashell, clams, things like that, oysters, that's modern day stuff, but things with shells like that, those are bivalves. Gastropods, things like snails, so they have that hard shell but the soft body. Bryozoans, which are kind of these mossy sea little creatures, and some crinoids. Love a good crinoid, also known as sea lilies. We also get the first coral reefs to appear during the Ordovician. Coral reefs are a buildup of coral. Individual coral came about in the Cambrian, but we start to see kind of a buildup of these corals into reefs in the Ordovician. Okay, so here's a crinoid, also known as a sea lily. So we start to get some snails. Here are those bivalves, again, the things with two sides to them. We get some other stars, some other little shelled creatures, gastropod shelled creatures. But again, still mostly life in the seas, but we're starting to get some plants onto land. Remember those lycophytes I'd mentioned? This is kind of modern day kind of examples of what kind of these would have looked like, these lycophytes that evolved during the Ordovician on land. Very, very small, kind of very interesting, weird looking plants. So life's still mostly in the ocean, but we're starting getting these little plants onto land. At the end of the Ordovician, we get the Ordovician-Silurian extinction. Now, a little misconception about extinctions. Extinctions don't happen all of a sudden. They happen over a period of time. And often that period of time is like millions of years. All right? So during this, more on that in just a second, but during this extinction that marked the end of the Ordovician and the entrance and beginning into the Silurian, about 86% of all life was lost. Right? And that's all 86% of all the different creatures on Earth that was lost. Right? Again, this was the hypothesis was there was a glaciation that occurred. abundant plant life, now that we're starting to get plant on land, kind of removed carbon dioxide from the air, caused global cooling, which caused further glaciation. It's led to a drop in sea levels, again, losing that shallow ocean environment where most of these organisms were living at. And then after that, we start to get global warming, sea levels rise. But again, the organisms that couldn't adapt to the lower sea level and the cooler climate, they pretty much died off. Okay. The extinction itself lasted for 5 million years. Okay. So again, extinctions aren't just, oh my gosh, they were here, they're not. When the dinosaurs, as an example, went extinct, we'll talk about that in a later unit. Yes, there was an asteroid impact, but there was stuff going on before it and stuff after it that was going on. So it was a larger extinction event. This extinction event took 5 million years. It's a lot of time. Geologically, that's a blink of an eye, yes, but in our frame of reference, extinctions take a while. So again, marine communities were devastated. This was the first major extinction event we see in the fossil records. Again, it was thought of when the big chunk of land, Gondwana, kind of was moving around the Earth, and now all of a sudden it's at the South Pole, it's cooling down, and glaciation occurs with the plants on land. It's taking carbon dioxide out of the atmosphere, which cools the planet. The more carbon dioxide we put into the atmosphere, like what we're doing now with burning fossil fuels, traps heat. So the more carbon dioxide in the atmosphere traps heat, making it warmer. Less carbon dioxide, hence global warming. Less carbon dioxide doesn't trap as much heat, so it's going to be cooler. So you got plants taking carbon dioxide out of the atmosphere via photosynthesis. The atmosphere is getting cooler, so multiple things are kind of adding up to this extinction event. There's evidence for this glaciation in the Sahara Desert, which now is very hot and dry, but we have evidence, geologic evidence of this. And again, it's when this big chunk of Gondwana, which is now modern-day Africa and parts of Asia, this was at the South Pole. Yeah. So as far as marine fossils in the Ordovician, again, we start to get, these bivalves, brachiopods. We still have some trilobites and some other kind of moss-like bryozoan, kind of this, but these are animals, believe it or not, very tiny little creatures. But this is kind of what we're looking at, and then we get this extinction heading into the Silurian. This is kind of in the later part of the Ordovician. We can see the ice, the glaciation in Gondwana, again, what would be modern-day Africa and parts of Asia, and that caused sea levels to drop, part of which led to the extinction at the end of the Ordovician. So again, here in the Ordovician, we're going to get into the Silurian. In the next section, we start to talk about the more corals. We started to get that in the Ordovician, but we're going to get more what we know of modern day type corals. More fish, again, those started back in the Cambrian, but more fish, again, maybe starting to think about things that look similar-ish to what we have now. Plant life, again, during the Ordovician, simple algae starting off in the oceans, but kind of making its way onto land, and these weird little lycophytes and even bryophytes, some mosses on land. And then as we get into the Silurian and Devonian later on, we start to see ferns develop and conifers a little bit later on, things we kind of know about. And here's a little interesting fact, flowers. Flowers didn't evolve on Earth until the Cretaceous period, which is in the Mesozoic, which is 300 plus million years away from what we're talking about right now in the Silurian. So it's not until about 300 million years later, during the Cretaceous, that flowers evolve on land. Dinosaurs were already a thing in the Triassic, Jurassic, and Cretaceous, and then flowers kind of came about. Sometimes that boggles the mind for me. The Earth is a fantastic place and a great story. But anyway, you know what? Before we go, let me give you the first part of the super secret code. It is the number 5. You got me? The number 5. One more time. The number 5. So we'll pause there, and I'll see you back here in a second, and we'll talk about the Silurian period.